Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's get to lesson 4.2.4. This is the last lesson that's going to pertain to all the information we've been learning so far in Chapter 4. The Chapter 4 test is going to be coming up right around the corner. So this is where we're going to connect the representations of proportional relationships. And so this is kind of like a web of proportionality. The constant of proportionality is like your unit rate. You got a word problem and you figure out from that word problem what the unit rate is. Once you know what the unit rate is, you can set up a table with different values. You can take those values and put them into ordered pairs and graph them, and we can also create a rule for that situation. And so what we want to be able to do is we want to be able to go back and forth between any of those representations. For instance, if I see a graph, I want to be able to create a table from that graph, and from that graph figure out what the unit rate is. And from that, then I can figure out what the rule is and then use that rule to solve other problems related to this situation. Okay, so do I want to read all through this? You might as well. In the previous lessons, you studied different ways to represent proportional relationships. You organized information into tables and graphs. You also wrote equations modeling proportional relationships. Proportional relationship equations are in the form y equals kx, where k is called the constant of proportionality, but I also want us to think of it as the unit rate. Okay? Today, you will find connections between different representations of the same proportional relationship. Explore each representation more deeply and learn shorter ways to go from one to another. As you work today, keep these questions in mind. How can you see the growth in the rule? How do you know your rule is correct? What does the representation tell you? And what are the connections between those representations? All right, so here's a situation with Graham. He earns $4.23 for each half hour that he works. Okay, so that's important information. How much does he earn during any given amount of time? So the first direction is to represent this situation using a table. So I would like for you to create a table and have the number of hours that he works be listed across the top, and then cost, or I should say his earnings. That would be a better way of putting that. He's not spending money, he's earning money, isn't he? Doobie-doobie-doo, let me do, oh, I better move this guy over a little bit. No, boo, hold on, I'm pausing. All right, that's much better. That makes more sense. Okay. So the number of hours that Graham worked and his earnings, and the provided information was for half hour of work, he makes $4.23. So what I would like for you to do is to create this table with these numbers for the number of hours that he works, and then fill in each one of these dollar amounts. So if he works 1 hour, how much does he make? If he works an hour and a half, how much is that? 2 hours, and so on and so forth. All right, so let's take a look at this. If we know that he makes $4.23 in a half hour, then if you double the half hour, you're going to get how much he makes in an hour, right? And that would be our unit rate. So if we think about this, what would you multiply times 1/2 to give you 1 hour? Well, that would be the number 2, wouldn't it? So if we double the time that he works, that'll double the amount of money that he makes. Therefore, in 1 hour, he would make $8.46, which happens to be the unit rate. So this is what we would call the constant of proportionality. If you think about that rule, y equals kx, the k, that's the unit rate. That's the constant of proportionality in this equation, where x is the number of hours worked and y represents the earnings. So when we put all that together, we can see our unit rate is going to be $8.46 per hour. That's the number that we put into this into this equation. So let's keep going. If 1 hour is $8.46, then 2 hours has to be twice that, correct? So what is 2 times $8.46? Well, that's going to be $16.92. And we could take Since 1 1/2 is the same as 3/2, we can multiply this times 3, and that would give us this number. Or 1 plus 1/2 is equal to 1 1/2. So $8.46 plus $4.23 gives you $12 and what is that? 69 cents. Absolutely. And then if we want to add the $2, I'm sorry, the 2 hours, which is 16.92, to the half of an hour, we could get this. Or let's just go ahead and use our unit rate. If we know that the rule for this is going to be $8.46 per hour times the number of hours, then when I multiply this times $2 or 2.5 hours, that's going to give me the amount right here. So let's go ahead and do that instead of trying to do some mental math here. So let's take $8.46 and multiply that times 2.5. And that was the number I had up there when I pulled up the calculator. It's $21.15. So Y would be $21.15 for 2.5 hours worth of work. And so the great thing about creating these rules is that I can now plug in any number for X. If you want to find out how much he's going to make working 20 hours a week, we can do that by multiplying $8.46 times 20. If he only works 19.5 hours, then we just multiply times 19.5. But we're able to use this rule now to get us pretty much any dollar amount that we want. So how could you use the table to determine if a relationship is proportional? Well, remember, you're looking for 0, 0, and you're looking for a constant growth rate. And in this case, since we are going in order, 0, 1/2, 1, 1.5, 2, 2.5, means there's going to be a constant growth rate where every single time it's going to increase by $4.23. Or every time you go up an entire hour, it's going to increase by $8.46. Okay? We could also look at this and say your unit rate, if you multiply your unit rate, that's your constant multiplier. 1 times your unit rate is this, 2 times your unit rate is that, 1/2 times your unit rate is this, and so on and so forth. So that constant growth rate or that multiplier in conjunction with 0, 0 being a part of this makes everything proportional here. All right, now let's look at something different. Jamie ran 9.3 miles in 1.5 hours. So how far can she run in any given amount of time if she runs at a constant rate? So once again, they're telling us that it's a constant rate of speed, but we're going to call it an average rate of speed. And does 0, 0 apply in this situation? Yeah, if you spend no time running, you're not going anywhere, right? So 0, 0 does apply to this situation, which makes it proportional in nature. So what we're going to do is this. We're going to say, all right, there are 2 points that we can graph on this graph. 0, 0 is absolutely one of them. And the other one would be 1.5, 9.3. Now, depending on how you scale your axes, it might not be super easy to find these exact points. That's not too bad. But finding 9.3 could get a little tricky, so we got to be careful. So what I want you to do is I want you to create a coordinate grid. We know that 0, 0 is going to apply to this situation because it's proportional, so you know you're going to be putting a point on the origin. I'm going to recommend we scale this out a little bit. Actually, we're counting by quarters. So this is 1/4, 1/2, 3/4, 1, 1 1/4, 1 1/2, 1 3/4, 2. But we're only going to focus on 2 points to start off. One of them is the 0, 0. And the other one is where x is equal to 1.5 and y is equal to 9.3, which brings up the scaling for the miles on the y-axis. I chose to count by 2.5s. You could count by 1s if you wanted to. You could count by 5s if you want to. You can count by really whatever you want to. But if you reproduce this graph, we should be able to get a pretty decent looking graph and be able to interpret it fairly well. So go ahead, reproduce this in your journal, and then plot the origin 0, 0 and 1.5, 9.3, and then we will connect those points with a straight line and see what other points fall on that line. All right, did you take enough time? Did I give you enough time? It seemed like a split second, didn't it? Because I paused, and I always do that, and I always give you plenty of time while I'm making the video, realizing that you pausing and unpausing or me pausing and unpausing really is a matter of a millisecond as far as this video is concerned, but whatever, I'm just babbling right now. All right, let's see what we got. Let's take, and I plotted a few points here. This is the 1.5, 9.3, and I'm going to go ahead and put a line through those 2 points and see what else falls on that point. Now, how do I know that this is 9.3? Do I really know? Does that look like it could be 9.3? Because, you know, the way that this is being scaled, this is 5, so that would be 7.5. So 8 would be right around here. The 9 would be right around there. And it's somewhere in there. You know, it's hard to get it perfect, if you know what I mean. So why did I plot this point right here? Well, because we need to stop it. We need to find the constant of proportionality. So on the graph, the constant of proportionality is going to be the point where x is equal to 1. But how do I know for sure that that's the constant of proportionality? Because that is the unit rate, right? And I can find the unit rate for this situation by taking the information that I know. 9.3 miles in 1.5 hours is going to be equivalent to how many miles in 1 hour? So remember, when you find the unit rate, it's really just a matter of doing this division, 9.3 divided by 1.5. So let's go ahead and do that. 9.3 divided by 1.5, and our answer is 6.2. So X says that 6.2 miles per hour is our unit rate. That's the constant of proportionality. So that means for every 1 hour, you travel 6.2 miles. That's basically what that is saying. So that is going to correspond to this point. And sure enough, does that point show up? Does that look like it could be about 6.2? I think it does, right? Because 5, 6, 7, then that's 7.5. That is, I think that's pretty accurate. Okay, so how can you use the graph to determine if a relationship is proportional? What are the two things that we're always looking for? We are looking for a straight line. That implies the constant growth rate. And 0, 0, that's the origin. Okay, now I do want to test one point here and make sure that it works. Because if that is the constant of proportionality, that's the unit rate, then our equation would be 6.2 miles per hour times x. And actually, you know what I might do here? Now, remember the formula D equals RT? Have you seen that before? Because this is a proportional type of a situation where the rate of speed is 6.2. T is the amount of time, right? That's the number of hours. And D is the distance, in this case, in miles. So this is a D equals RT kind of an equation. We just are using X and Y instead of the D and the T. But the R is the rate of speed, right? Miles per hour. That is the rate of speed there. So in that case, R is the unit rate or the constant of proportionality. So let's come to here, right there. What does this point appear to be? When X is equal to 3, what does this end up being right there? So this is 15, 17.5. Is that going to be right around 18? 18 point something? Let's check and see what that is. When X is equal to 3, what is Y going to be equal to? So 6.2, stop it. And 6.2 times 3, that's 6. That's an 18. We've got 1 decimal, so we're going to put that back into the answer. Does that look like it could be right around 18.6? It does. So our graph can now be used, if you stretch it out, can be used to find pretty much any value for Y, although it's still not really clear that that's 18.6 there. I had to use the rule anyway. So I guess the moral of the story is there's nothing better than using a rule to find out all the information we need to use. But graphs are good visually. Tables are great for observing patterns, but nothing is better than the rule. Right. I think this one is going to be more about using the rule. So it says a recipe calls for 2 2/3 cups of flour to make 2 regular batches of cookies. Shiloh needs to make multiple batches. So let's figure out what the unit rate is and put that unit rate into an equation so we can use that to find any number of cups of flour for any number of batches. Okay, so what we're going to do is we're going to set this up. That's our ratio, correct? Or our rate. 2 2/3 cups is the same as 2 batches. So to find the unit rate, we need to figure out how many cups there are in one batch. So it looks like we have to take half of 2 2/3. So I want you to pause the video and see if you can figure that out. What is 2 2/3 divided by 2? Okay, this is a good opportunity for us to practice dividing with mixed numbers. Okay, so if I were to write this as 2 and no, that's 2/3 divided by, that's sloppy. I can't have that. I'm sorry. Hold on. 2 2/3 divided by 2 is the same as 6 7 8/3 times 1/2. It's going to end up being 8/6, which is the same as 4/3, which is the same as 1 1/3, right? Dividing, instead of dividing, multiply times the reciprocal, then simplify the fraction. So 4/3 is the same as 1 1/3, which means 1 1/3 is our unit rate. Sorry, it's not erasing as quickly as I would like. There we go. So let me go ahead and get rid of that guy so you can see. Oh, are you kidding me? Ooh, hold on. I'm going to fix this. I had no idea it would go through that. That's what we want. Okay. Sorry. So this is our unit rate, which means that's our constant of proportionality. So when we multiply x times a number, x being the number of batches, y is going to be that number times 1 1/3. So the constant of proportionality is the unit rate, which is 1 1/3. And how can you identify it in the equation? Well, it's simply the number that's being multiplied times x. Remember, if y equals kx is the generic form of a proportional equation, the constant of proportionality is the unit rate, and that's the number that's being multiplied times x. So now, how can you use an equation to determine if a relationship is proportional? Why don't you spend a couple of minutes and see if you can figure out how to respond to that, okay? And then write down a little response and see if you get the same thing as me. All right, how can we use an equation to determine if a relationship is proportional? Well, you're going to multiply the unit rate times whatever x is equal to, and that's going to give you your value for y, correct? So with that being the case, if you're looking at the equation, and this is in fact the equation, then when you multiply x times 0, you should get y is equal to 0 as well. That's how you check the 0, 0. One thing that you'll notice, and we mentioned it, I think once before, in maybe homework or in a lesson, if there's nothing being added on at the end, then whatever, if x is 0, then y has to be equal to 0 too. If you were adding something on the end and x was equal to 0, then y would be equal to whatever that number was that you were adding at the end. So think about the 50-cent cup for the jelly bean yogurt situation. Adding 50 cents per cup, that changed it so it was no longer proportional. So it has to be in this form. And so when x is 0, 0 times anything gives you y is equal to 0. Alrighty, and I think that ends our lesson for today. So let's move on to our next activity, which possibly is a check for understanding. Not quite sure if we've got that or not. Could be just doing our homework. All right, take care. Bye.
Hey, feeling good.